Valens is the high-performance connectivity company. It's not just high-performance connectivity, it's the best one out there. We are so confident in that we have put together a technology shootout live at CES. Let me walk you through it. This is our setup. Here we have our transmitters. One is the Valens VA7000 series running at 8 gigabits per second. The other is a competing legacy solution running at 6 gigabits per second. Both are connected with identical cables up to their respective receivers. We've attached a signal generator that injects noise into the links to test the robustness of the receivers. The images are shown on the screen. On the left side, you see the competition. On the right, Valens AFI compliant chipsets. Let's start with the competing solution, starting at -14 dBm and working our way up. As you can see, at just -13 dBm, this solution fails to withstand the noise. While the Valens VA7000 chipsets continue to withstand the injected noise, let's crank it up to 0 dBm, 10 dBm. It's still working. Finally, at +14 dBm, the link fails. Let me put this into perspective for you. The Valens solution is withstanding 20 times more noise than the competing solution. Now, our competitors may say that this is overkill. Why do we need such a high level of robustness to EMC? Well, while they may have been doing fine so far, there are several pitfalls lying ahead. As OEMs integrate ever higher resolution sensors into their cars, there are higher bandwidth requirements on the SerDes and reduced margin for error. It remains to be seen how these SerDes will perform over high bandwidth links. We suspect, though, it won't be well, especially in light of cable aging. Our competition relies on shielding to keep the noise out of the cable, but research shows that shielding degrades with time and stress. Shielding that kept the noise out of a link when the car drives off the lot will be much less effective a few years later as the link suffers the wear and tear of daily driving. So how do we do it? What makes the Valens VA7000 series the most EMC robust SerDes on the market? It really comes down to 4 key mechanisms enabled by our DSP-based approach to EMI. First, the Valens chipsets utilize high levels of pulse amplitude modulation. While competing solutions use PAM2 or PAM4, MIPI AFI solutions reach PAM16, allowing us to encode more bits per symbol, leading to reduced link frequencies, lower signal losses in the cable, less transmit power, and lower radiated emissions. Second, we have fully adaptive equalization, which compensates for channel insertion loss throughout the length of the cable. Third, we have just-in-time noise cancellers that are optimized for the harshest EMI in the automotive industry, narrow band interferences. Lastly, we have a unique retransmission mechanism that operates at the PHY layer. We call it DMLR, Dynamically Modulated Local Retransmission, and it is far more capable of handling automotive EMI than FEC, which is used by competing analog-based solutions. These unprecedented EMI capabilities allow us to outperform competition in many aspects of high-performance connectivity, including link distance, the ability to run over UTP cables, lower radiated emissions, and the lowest in the industry error rates. The technology can scale to support higher bandwidths, while legacy analog solutions have hit a wall. So if you care about EMC as much as we do, and you want to make sure that your car is as protected as possible from this safety-critical issue, please connect with us. We welcome any challenge.